Okay, now we're moving on to our chemical weathering portion, and I'm still continuing to read, but we're now on the chemical weathering components. So it says, in addition to mechanical weathering, another type of weathering attacks rocks. Chemical weathering is the process that breaks down rocks through chemical changes. The causes of chemical weathering include the actions of water, oxygen, carbon dioxide, living organisms, and acid rain. So for chemical weathering, here's my definition. Chemical reactions break down the bonds that hold rocks together, forming new substances. Again, I've kind of keyed in on some key terms, right? I'm breaking down bonds. I've kind of created like a little atom here or molecule here where they're breaking down because of the things surrounding it, like oxygen or hydrogen, things like that, carbon. New substances are formed. It's completely different for chemical weathering, unlike mechanical weathering, where it is still the same type of rock. Each rock is made up of one or more minerals. Chemical weathering can produce new minerals as it breaks down rock. For example, granite is made up of several minerals, including feldspar, quartz, and mica. As a result of chemical weathering, granite eventually changes from feldspar minerals to clay minerals. Chemical weathering creates holes or soft spots in rocks so that the rock breaks apart more easily. Chemical and mechanical weathering often work together. As mechanical weathering breaks rocks into pieces, more surface area becomes exposed to the chemical weathering. We are not doing a discover this investigation. Okay. Now we're going to talk about the different types of weathering. So we're first going to talk about water, which is this one right here. Water is the most important cause of chemical weathering. Water weathers rocks by dissolving it. When a rock or other substance dissolves in water, it mixes uniformly throughout the water to make a solution. Over time, many rocks will dissolve in water. So the reaction of rock minerals with H2O, which is the chemical formula for water, the water changes the composition and size of the minerals, and in some rocks, making them easier to break apart. This is called hydrolysis, specifically. Oxygen. The oxygen gas in the air is an important cause of chemical weathering. If you've ever left a bicycle or metal tool outside in the rain, then you've seen how oxygen can weather iron. Iron combines with oxygen in the presence of water in a process called oxidation. The product of oxidation is rust. Rocks that contain iron also oxidizes or rusts. Rusts make rocks soft and crumbly and gives it a red or brown color. So oxygen is our next one, and it says the reaction of rock minerals with oxygen and iron containing rocks oxidizes or rusts when water, iron, and oxygen combine. So this is called oxidation. So I've added in some like O2 symbols, which is oxygen, their chemical formula. I added in Fe, which stands for iron. That's the iron's chemical formula. And with these two combining, it is Fe2O3, and that is what we call rust, commonly known as rust, or iron oxide. Carbon dioxide, we're going to move on to that one. Another gas found in air, carbon dioxide, also causes chemical weathering. Carbon dioxide dissolves in rainwater and in water that sinks through air pockets in soil. The result is a weak acid called carbonic acid. Carbonic acid easily weathers rocks such as marble and limestone. And you'll learn more about this in checkpoint 1 of our geology story. So the reaction of rock minerals with carbonic acid. So like that rainwater can become an acid by absorbing carbon dioxide in the air. Carbonic acid weathers the rocks such as marble and limestone. So this is called carbonation, and this is how actually caves are formed. We have two more to talk about: living organisms and acid rain. So living organisms. Imagine a seed landing on a rock face. As it sprouts, its roots push into cracks of rocks. As the plant's roots grow, they produce weak acids that slowly dissolve rock around the roots. Lichens, a plant-like organism that grows on rocks, also produce weak acids that chemically weather the rock. So I tried to create this like rock with this kind of like moss-looking things that's actually supposed to represent lichens. So I wrote, as plant roots grow, they produce weak acids that slowly dissolve the rock around the roots. Lichens, plant-like organisms, can produce weak acids that chemically weather rocks. And finally, acid rain. Over the past 150 years, people have been burning large amounts of coal, oil, and gas for energy. Burning these fuels can pollute the air with sulfur, carbon, and nitrogen compounds. Such compounds react chemically with the water vapor in clouds, forming acids. These acids mix with raindrops and fall as acid rain. Acid rain causes very rapid chemical weathering. Okay, so I put pollution in the air from burning coal, oil, and gas creates sulfur, carbon, and nitrogen. These compounds react chemically with water vapor in clouds, forming acid rain, which causes rapid chemical weathering. So here's my factory polluting the air, and then it's raining over here on these different rocks, right? Okay. Last but not least, we're going to read about rates of weathering. I did not add it in here, but it's just really good information to know. Again, you'll use these notes so that you can study from them before you take your content assessment for Water and Earth 2. Rate of weathering. Visitors to New England's historic cemeteries may notice surprising facts. Slate tombstones carved in the 1700s are less weathered and easily to read than the marble gravestones from the 1800s. Why is this so? Some kinds of rocks weather more rapidly than others. The most important factors that determine the rate at which weathering occurs are the types of rock and the climate. So the type of rock. The minerals that make up the rock determine how fast it weathers. Rocks made up of minerals that do not dissolve easily in water weather slowly. Rocks made of minerals that dissolve easily in water weather fast. Some rocks weather more easily because it is permeable. Permeable means that the material is full of tiny connected air spaces that allow water to seep through it. Permeable rocks weather chemically at a fast rate. Why? As water seeps through the spaces in the rock, it dissolves and removes the material broken down by weathering. Climate refers to the average weather conditions in an area. Both chemical and mechanical weathering occur faster in wet climates. So water is huge for both of these processes to happen. Both chemical and mechanical weathering occur faster in wet climates. Rainfall provides the water needed for chemical changes as well as for freezing and thawing. Chemical reactions occur faster at higher temperatures. That is why weathering occurs more quickly where the climates are both hot and wet. Granite, for example, is a very hard rock that forms when molten material cools inside the earth. Granite weathers so slowly in cool climates that it's often used as a building stone. But in hot and wet climates, granite weathers more rapidly and eventually crumbles apart.